Hello and welcome again to our second video. You have all heard the term water current, and this takes us to the term electrical current to see clearly that there is an analogy between water and electricity. This picture says much of it. In this picture you can see what we have learned about batteries or power sources, that they make some kind of voltage difference so that they move electrons through a closed loop, a closed circuit, causing some load to make some work. The load could have been the light bulb, but here it is represented with a fan to make probably more analogy with the water wheel that we will see in the water system. In the water system, instead of the battery, we are going to have some water pump, which again pressurizes water to move pipes instead of wires, passing through this water wheel and causing it to move, which is the load, and its movement is the work that we needed to do, and returning back and going through and through the system as long as the water pump is working. And here we will go as long as the battery is charged. So more formally, we can say that there is some analogy. I'm symbolizing with this arrow to analogy here between electrical and water systems and components. So speaking about components, we said that the power source has analogy with the water pump. The load, in that case it was the fan, and here we wrote the bulb. It has analogy with water wheels. Notice that water wheels will cause some constriction to the passage of water through the pipes. It will cause some kind of opposition that slow the water or make it difficult for the water to pass by. This is why the load is also named as resistance, as we saw in video number 1 in our electrical systems. Although not in that drawing, but here in this drawing we can see that the switch is analogical to the tap. If you open the tap or close it, the valve, you can have the water flow in the system. You can also see that there is a tank. Having a high tank is analogical to having what we call voltage. This is the first time we speak about these two very important terms, voltage and current, which are not components anymore, but they are measures or amounts that are used to describe a system of electrical circuits. Voltage is analogical in our analogy to the height of a water tank. The higher the water tank, the more potential it has to give pressurized water, or water that can cause higher work. Only if the water is allowed in the pipes, we will have that. So voltage is the potential to make work in electrical circuits. You can imagine it as a higher tank on, say, the 12th floor of a building compared to another tank which is only on a first floor of a building. They will have different potentials to produce work if the tap is open. Current is probably one of the most visible analogies between the two systems. Water current refers to the amount of water that passes through a pipe section in 1 second. Similarly, electrical current will be the amount of electrical charge that pass through a section of a wire in 1 second. So they are analogical to each other. Current is measured in amperes and voltage is measured in volts. Enough for this short video, and next time, have heads up, we will speak about Ohm's law. Thank you very much for attending.